This example is similar to the previous one with one exception. Even though we do have down here dy dx, we now have both x and y in this differential equation. So we're going to have to take both of those variables into account when we're finding the slope of the tangent line. To find the slope of the tangent line for each point, we're going to just arbitrarily pick a point. Doesn't matter which one it is. Why don't we just pick, -2, 2 here for this one. So if we choose -2, 2, and we try to find dy dx, all we need to do is just substitute in those values for x and y. So x is -2, y is 2, and we wind up with -2 minus 2, which gives us -4. So when I draw the tangent line, hopefully I can erase this piece right here. There we go. When I draw that tangent line, what I need to do is I need to draw the slope of a line that is about -4, or at least as close as I can get to -4. For the AP exam, they're not going to look to see whether your tangent line approximation there is going to be exactly -4 for a slope. They will check to make sure that the slope is negative. Or for each slope that's horizontal or 0, they will make sure that those are exactly flat horizontal lines. And then every slope that's positive, they're going to make sure that those slopes are positive regardless of what the actual number is, 1, 2, or 3. Let's keep going with a few more points, and the process is similar here. So let's choose -2, 1 as our next point. And if we substitute those values in for x and y, we wind up with -2 minus 1, which is -3. So slightly less steep than the previous one that we just did, but still fairly steep. If we move down to -2, 0, -2 minus 0 is -2, so a little less steep than the one before. And then if we go even further down to -2, -1, we'll have -2 minus -1, which actually happens to be -1. Once again, we're just substituting the x and the y from the point into the differential equation, which is highlighted in blue on the left-hand side. At -2, -2, we have -2 minus -2, which is -2 plus 2. So the slope here is going to be 0. And I forgot to do my other point here at the top. So we'll do that one next here. We're going to go all the way to the upper left-hand side. When x is -2 and y is 3, -2 minus 3 is -5. So even steeper than the other line that we drew, but still having a negative slope. We're going to work through each one of these, and we're going to see something that might appear here. And we're going to take a look and see if we see any patterns as well. For instance, at -2, -2, I know that my slope is 0 because I'll have one number and then the opposite of the same number. So if I look at -1, -1, -1 minus -1 is also 0. And if I go to the origin, 0, 0, that would be 0 minus 0, which is also 0. And I can keep this type of thinking with 1, 1. 1 minus 1 is 0, and 2 minus 2 is 0. So the key with these is to look for patterns and see if you can determine anything that might appear. Let's take a look at now diagonally -2, -1. The slope there was -1. And if we take a look at -1, 0, -1 minus 0 is also -1. So that same pattern kind of applies here as we move diagonally from lower left to upper right. When x is 0 and y is 1, we have 0 minus 1, which again happens to be -1. So I'm going to try to draw that slope here at -1. And the same thing is going to happen here at 1, 2. 1 minus 2 is -1. And then 2 minus 3 here is also -1. So it looks like those slopes are the same on the diagonal. So we'll try to see if we can do the same thing for -1, 1. That's a slope of -2, which might look something like this. And that should hold true also for 0, 2. 0 minus 2 is -2. We can do the same thing here. And then we'll draw a slope of -3. utilizing my pattern right here. And then this slope should be -4, same as the one that's diagonally to the bottom left here. And we can continue this type of thinking as we move down to the other side of the graph. Let me go ahead and just figure out what -1, -2 would be. So -1 minus -2 happens to be +1. And if I think about the next point to the upper right diagonally, I've got 0, -1, and 0 minus -1 is +1. So all of the slopes of these points should be +1. Let's try 0, -2. So 0, -2, that would be 0 minus -2, which is actually +2. So I'll try to draw a slope of maybe +2 here. And once again, our thinking with the diagonal piece is going to work as well. That's a little bit too high sloped right there, but it'll work for what we're doing. And then we've got 1, -2, and the slope there will be 1 minus -2, which is 3. So we'll draw even a little steeper. Try to draw that a little steeper if you can. And then the slope here, 2, -2, would be +4 because 2 minus -2 is +4. And we have a shape that kind of is emerging, although we don't know where to draw that. So in one of the next examples, what we're going to do is we're going to actually be drawing solution curves, which is what the original equation might look like. And that's one of the things that we use slope fields for. It turns out with this differential equation, we actually can't find the original equation that looks like this. However, we do know some things about it if we can draw this slope field.